Hi everyone. Today in this video I am going to solve examples on indeterminate forms of 0 by 0, infinity raised to infinity and 1 raised to infinity. So let's get started. Indeterminate forms of indeterminate forms of 0 raised to 0, 0 raised to infinity raised to infinity and 1 raised to infinity. Let u is equal to limit x tends to a f of x raised to phi of x, f of x raised to phi of x. Now in such cases, taking log on both these sides, taking log on both sides, so left hand side you will get log u is equal to, right hand side we can write it as logarithm of limit x tends to a f of x raised to phi of x is equal to, this same term we can also write limit outside the function, so that is limit x tends to a, and we can send log inside the bracket, logarithm of f of x raised to phi of x is equal to limit x tends to a. Now you can apply logarithmic property, log u raised to p, we can write it as p into log u. So in place of p we have phi of x, and in place of u we have f of x. So we can write it as phi of x into logarithm of f of x. This is log u. Now this is will be in the form of 0 into infinity. Now this 0 into infinity you can change to the form of 0 by 0 or infinity by infinity, and then solve by using L'Hospital's rule. You will get a constant number, and let us say that constant number is equal to L. So log u is equal to L means after simplifying this limit you will get the value L, that is say, then transpose log to the right hand side, u is equal to e raised to L, which is the required limit. Evaluate limit x tends to 0, limit x tends to 0, x raised to x. Okay, let u is equal to, let u is equal to limit x tends to 0, x raised to x. Now taking log on both the sides, logarithm of u is equal to logarithm of limit x tends to 0 x raised to x. Now the same term we can also write it as, you can take limit outside the bracket. So limit x tends to 0 logarithm of x raised to x. Now by using logarithmic property, this log x raised to x, we can also write it as limit x tends to 0 log x raised to x, we can also write it as x into log x. If you substitute x is equal to 0, this is 0, and if you put x is equal to 0, you will get 0 into infinity form. So now we can change to the form 0 by 0 or infinity by infinity. For this we can write limit x tends to 0, limit x tends to 0, I will keep log x as it is and transpose this x in denominator, you will get 1 divided by x. Now by using L'Hospital's rule, if you put x is equal to 0 here and put x is equal to 0 here, you will get infinity by infinity form. So by L'Hospital's rule, by L'Hospital's rule, this is equal to limit x tends to 0. What is differentiation of log x? Differentiation of log x is 1 divided by x divided by. What is differentiation of denominator 1 by x? Differentiation of denominator 1 by x is minus 1 divided by x square. If you simplify this, you will get that is equal to, left hand side we have log u, and this is equal to limit x tends to 0. One of the x get cancelled. So on simplifying, transpose the remaining terms to the numerator, you will get minus x. And this is equal to, if you put x is equal to 0, you will get 0 here. So log u is equal to 0. Transpose log to the right hand side. U is equal to e raised to 0 and u is equal to e raised to 0 is 1, which is the required limit. Second example, evaluate limit x tends to pi by 2, limit x tends to pi by 2 cos x raised to x, cos x raised to cos x only, not x, cos x raised to cos x. So here also I will write u is equal to limit x tends to pi by 2 cos x raised to cos x. Taking log on both these sides. So log u is equal to, now I will write directly limit x tends to pi by 2, I will write as it is and I will apply log inside the bracket. So that is log cos x raised to cos x is equal to, by using logarithmic property, we can write it as limit x tends to pi by 2 cos x into logarithm of cos x is equal to limit x tends to pi by 2. Now I will keep log cos x as it is. transpose this first term in denominator, we can write it as 1 divided by cos x is equal to limit x tends to pi by 2 log cos x divided by sec x. This is log u is equal to. Now similarly, by using L'Hospital's rule, by L'Hospital's rule, log u is equal to limit x tends to pi by 2. What is differentiation of numerator log cos x? Differentiation of log cos x is 1 divided by cos x into differentiation of cos x is minus sin x divided by what is differentiation of denominator sec x? Differentiation of denominator sec x is sec x into tan x. Okay, this is equal to limit x tends to pi by 2. Now what is remaining term? Minus as it is sin x by this cos x. Sin x by cos x is equal to tan x divided by sec x into tan x. This tan x and tan x get cancels. Limit x tends to pi by 2. Remaining term is minus 1 by sec x, and minus 1 by sec x is equal to minus cos x. If you put x is equal to pi by 2 here, you will get minus cos pi by 2 minus cos pi by 2, and cos 90 is equal to 0. So log u is equal to 0 means u is equal to e raised to 0, and e raised to 0 value is 1, which is the required limit. Next example, evaluate limit x tends to 1, limit x tends to 1, 1 minus x square raised to 1 divided by logarithm of 1 minus x. Okay, I will write here, let u is equal to limit x tends to 1, 1 minus x square raised to 1 divided by logarithm of 1 minus x. Taking log on both the sides, log u is equal to limit x tends to 1 logarithm of 1 minus x square raised to 1 divided by logarithm of 1 minus x. By using logarithmic property, if you apply logarithmic property to this term, we can write it as limit x tends to 1, 1 divided by logarithm of 1 minus x into logarithm of 1 minus x square, that is log u raised to p is equal to p into log u. Now by L'Hospital's rule, by L'Hospital's rule, this is equal to limit x tends to 1. What is differentiation of log 1 minus x square? Differentiation of log 1 minus x square is 1 divided by 1 minus x square into minus 2x divided by. What is differentiation of denominator log 1 minus x? Differentiation of denominator log 1 minus x is 1 divided by 1 minus x into differentiation of minus x is minus 1. This is equal to log u. Left hand side we have log u is equal to limit x tends to 1 minus 2x divided by 1 minus x square. This 1 minus x square we can write it as 1 minus x into 1 plus x. It has two factors, that is 1 minus x into 1 plus x. Okay, now transpose this denominator term in numerator. We can write it as minus into bracket 1 minus x, where these two terms get cancelled. So we are left with limit x tends to 1. This minus into this minus into this minus is equal to plus 2x divided by 1 plus x. Now simplify the limit means put x is equal to 1 here, and if you put x is equal to 1, log u is equal to, you will get 2 divided by 1 plus 1, that is 2 divided by 2, and 2 by 2 is equal to 1. Log u is equal to 1 means u is equal to e raised to 1, that is u is equal to e, which is the required solution. Try yourself. Try yourself. First example, evaluate limit x tends to 0, limit x tends to 0, sin x raised to tan x, sin x raised to tan x, and its answer is u is equal to e raised to 0, that is equal to 1. Next, second, evaluate limit x tends to infinity, pi by 2 minus tan inverse x whole raised to 1 by x, and its answer is u is equal to e raised to 0, and this is equal to 1.